Hi Fabio, welcome back.
Hey Adam, thanks for having me.
Do you know the last time when it was? Do you remember?
Oh, I can't remember. It's been some years, and a lot of things have happened since then.
Exactly, as there are 3 years. I just
Oh
look it up
wow,
right now and I couldn't believe it. Because for
yeah,
me it
that's
was
great.
very fresh and I wanted to reinvite you back, but I say no, you were last month here and maybe nothing happened. There were 3 years. And why we are here is, or why I really wanted to have you here is to talk about two things, or WASM related things. So WASM and Graal. This is what interests me for today. And I think last time we mentioned the Graal runtime for WebAssembly.
Yes,
So for me, it sounds like I can, if I have WebAssembly, I can run it on Graal, right?
yes, yeah.
Yeah.
Well, that is what we call GraalVM,
Mm-hmm.
and GraalVM is just a bunch of Maven artifacts. So you can run it on GraalVM, but you don't have to. You can even run it on OpenJDK or on Oracle JDK or something.
This is what I
Mhm.
knew. So
Yeah,
it means.
well, that's something that has happened in the last 3 years. So all of our languages, GraalPy, GraalJS, GraalWASM, and others, they've all been, we call this unchained. So they're no
Hmm.
longer chained to GraalVM. They are independent, more or less. Technically speaking, they're just Maven artifacts that you can pull and depend on. In the past, we would include them in the GraalVM distribution,
Hmm.
and there was no sane way to users to depend on them. They would make sure that they run on the right JDK, like GraalVM JDK, but that's no more. For more than a year now, all of them are just Maven dependencies. You can depend on them as you normally do in your projects, and then you can run, for example, WebAssembly on GraalVM in your
So,
Java applications.
so what it means from the architectural point of view that the polyglot and the runtime were separated. So you can have the polyglot part as a normal or usual Maven dependency without being dependent on the GraalVM runtime, right?
Exactly, exactly. In the past, and we still call it the polyglot runtime. It's the runtime that all of our languages run on, but it's just that it's just the shared infrastructure. And what we have done in the last years is to focus on embedding use cases. So in the past, we had these crazy demos where you call Python to Ruby and vice versa, and include JavaScript. And these days, we primarily focus on extending Java applications with the power of Python, with the power of JavaScript, with the power of WebAssembly.
Hmm. What's what I don't understand still is the GraalVM is for me like a specific virtual machine. So it's an OpenJDK compatible runtime. But
Mm-hmm.
if I get only the Maven dependencies to run,
Mm-hmm.
it is a kind of an interpreter, right? So I mean, this is you will still need a part of the GraalVM, otherwise,
Yeah,
yeah.
yeah, yeah. Well, to some extent. Well, all of our languages are just Java applications from the JVM point of view, right?
Hmm.
So they run on OpenJDK, and all of our languages are implemented in Truffle,
Mm.
which allows you to only implement an interpreter essentially.
Hmm.
So all of the languages we have written an interpreter, and the way we make this fast is with the Graal compiler. The Graal compiler can act as a guest language JIT at runtime. So what you can do is you can just run your GraalWASM Java application on GraalVM, which includes the Graal JIT. And then it will automatically see, oh, there's the Graal JIT. It will use the Graal JIT, and you'll get really, really good performance. On OpenJDK, you can even include Graal as a jar, as an additional jar, and then it will just do truffle compilation, what we call truffle compilation.
The having GraalVM or not is the matter of speed. So this is like a hook. So if you noticed GraalVM is there, so it uses specific JIT optimizations. If there is no GraalVM, it just uses stock JVM possibilities.
Exactly, and GraalVM really just is a JDK. If you're using Community Edition, it's an Open JDK. If you're using Oracle GraalVM, it's Oracle JDK. Plus, the Graal compiler compiled to native, so it speeds up very fast, it warms up very fast, and it's very efficient. And that the Graal compiler is used by default. So on OpenJDK, you need to reconfigure the top tier compiler if you want to do that. In GraalVM, we do that automatically. So GraalVM really just is a JDK plus the Graal compiler enabled by default.
Hmm. Yeah, it's more like conventional configuration for OpenJDK with some.
Exactly.
That's interesting. So what it means is to compare this Mandrel from Red Hat would be just the runtime optimization without the polyglot hooks, right?
Well, Mandrel is a bit special, I think. They still include the Graal compiler because Mandrel is designed to do native image compilation, right, for Quarkus. But I think they have ripped out all the truffle compilation parts. So
exactly.
I think Mandrel is unable to do truffle compilation. You would be able to run GraalVM on it, but it would only run an interpreter, which is fine for some use cases. But if you really care about like bleeding edge performance, then you really want the truffle compilation to be enabled.
No, I just wanted to understand the difference between Mandrel and GraalVM, because this Mandrel for me is GraalVM without polyglot capabilities. So what they I don't, maybe the WASM won't run there, but what it essentially is just the native compilation part. And everything else is removed. Exactly.
Yeah, exactly. And they use a different JDK as a basis. I think some Tamarind or something.
Exactly. Okay. So now I can have Maven dependency, pick a Maven dependency, and run WASM on it.
Yes.
Right.
Yes.
And this will run on my OpenJDK from whatever. So I could pick
21 or later.
Yeah. And why should I do this?
Well, so that's maybe like for WebAssembly, maybe we should step back a little bit and talk about what WebAssembly really is, because I feel like in the Java community, not a lot of people actually know.
Yeah.
They know that this is some sort of hype coming from the browser or from the web, but they don't really know where we are or where WebAssembly is. So WebAssembly, like if you check the website, it will say that WebAssembly is just a binary instruction format for a stack-based virtual machine, right? So for a Java developer, the easiest way to think about this is JVM bytecode, right? It's like an instruction set. And it's designed to be a portable compilation target. So again, just like the JVM can run Java, but also Kotlin, Scala, and so forth, right? But what this means is you can compile Rust, C, C++, Go code, all to WebAssembly. And then you can run it, for example, in the browser. So modern browsers, including mobile browsers, they have support for it, and it will immediately just run in the browser. And you can just reuse code or write more efficient code, because WebAssembly, for example, has access to SIMD. You can do vectorization, something that you cannot do in JavaScript, right? So that's interesting for mobile devices. But in the last couple of months, WebAssembly has also gotten a lot of traction on clouds and in server-side environments. So now you can also use WebAssembly for server-side backends and essentially use it as a managed runtime. So all you do is you compile to WASM and you deploy it to some cloud provider and some WASM cloud, and they will take care of the rest. They can even sandbox the execution and provide more security guarantees than native code would otherwise do. So that's what WebAssembly is in a nutshell. And why would you want to embed this in Java? Well, as we all know, Java is a bit funky to extend at runtime, right? So you need to add something to the class path. You need to, first of all, you need to compile Java sources or some sources to JVM bytecode, put that on the class path, and then call it, right? But with WebAssembly, you could allow your users to extend your Java applications in a much simpler way, and also allowing them to do this with Rust, Go, C++, and whatnot, right? So you could, for example, have a middleware in a microservice, and you can let the user swap out the middleware at runtime, and they can do, for example, request filtering or enhancing request responses or something with additional headers. And they could do all of that in Rust, in Go, and in JavaScript, in TypeScript, right? So that opens up a lot of possibilities. And the fact that it's a portable compilation target is also very interesting. And I think one of the most interesting use cases could be portable native extensions in Java. Or if you want to use native extensions right now, you need to use JNI or Panama, right? And we all know what that means. It's a bit fiddly to set up, but also it breaks somehow this write once, run anywhere promise, right? You suddenly are in the business of shipping platform-specific dependencies, right? You need to ship the shared libraries for macOS, for Linux, for Windows, for x86, for ARch64, right? And that can be really annoying. What you could do instead is compile to WASM, and then that's portable, and you can include that and only that in your Java application, and it will run on all platforms. It may be compiled on a Linux computer or on a macOS computer, and some macOS or Linux specific code may run as part of that WASM module, but it will still do the same thing on all different platforms. And that is enabled by the WebAssembly System Interface, short WASI, which is also supported by GraalVM.
Oh, okay. So you're right. So especially all the cloud providers which provide how to call it, functions on the edge. Such functions are usually WASM functions.
Yes.
And so you could run them there. So regarding so GNI is out, I would say. FFM is nice. The problem with FFM we have is you need the native library somehow as well. So you will need a package, because this FFM is really nice. So I was surprised. I would really like to do something with it because you can just call it and you are done, right?
Yes.
But if I would build a microservice and would like to replace something, so I will have to replace, maybe I will manage to implement my Java application dynamic way, but I will have to replace the library to make it swappable, at runtime, or redeploy the entire system. But with WASM, there is no external dependency because the WASM is self-contained, like a bytecode. So I could...
Exactly. And what's also something to think about is when you're using Panama and you're using a microservices, they use virtual threads these days, right? And you want to scale your application, right? So that means you also need a way to call native code from these virtual threads, for example, or even just system threads. And then the best way to achieve very good throughput is potentially to instantiate your native code n times for n threads, and have every thread has their own instantiation of the native code, right? With and that's really hard because some native extensions, they're built in a bad way. They use lots of global state, and you can't easily load them multiple times, right? But with WebAssembly, you can just instantiate a WebAssembly module n times, and we even have what we call multi-context support. So you can create multiple contexts. You create a context per thread, for example, or you use a pool or something like that for that too. And then and then all of them will be isolated from each other. All these instances are isolated from each other, and the JITted code from the Graal compiler is actually shared across them because they're all the same module. They can share the JITted code, right? So we have all of these pieces already.
So at the AirHacks workshop at Munich Airport a few years ago, so I had a workshop about web and web components, and the problem they had is they had to move Swing application to the web. And what they had old signing or encryption code. It was specific and it was audited for compliance reason, and it was written in C. So what we talk about back then is we could actually pick the C, create WebAssembly, and load it to the web application. But now, even better, we can do the same and run it on the backend. So there is no need to ship, the WASM to the front end. We could do it on backend, and front end would just call the backend. So this would be also way better options because the WASM was big, and it's also in the browser is a little bit clunky to work with. Yeah. So and another thing is I guess FFmpeg or similar library or JPEG compression library is also available as WASM. So it means I could now, my microservices, I can use additional extensions where I had no chance to use before because I would never call FFmpeg via GNI, but now I can actually do this. So I would say now WASM is something like GNI on steroids without external dependencies, right? So this is what we do, and it's multi-threaded, which is pretty cool. So what was also a little bit, not interesting, I would say, not even challenging, how to pass parameters from Java to WASM. So I guess there's
So WebAssembly is very primitive. It's an instruction set, right? And that's where our other languages come into play. If you want to integrate WebAssembly right now, typically a compiler that compiles to WebAssembly also spits out a JavaScript binding, because all of this is designed to run on either Node, which can do JavaScript, or the browser, which can also do JavaScript, right? And fortunately, we have a JavaScript runtime, GraalJS, right? So what you can do to facilitate high-level interactions between Java and WebAssembly is put GraalJS in between and use the generated wrapper, right? So we actually have a demo for all of what I just described, multiple demos actually up on GitHub. There's a repository called Graal Languages Demos. I'm sure you put that in the show notes.
Yeah.
There we embed a photo processing library, an image processing library called Photon, written in Rust. And we exchange photo objects between Java and WebAssembly through JavaScript. All of that has a context pole and this has high throughput, and you can even do debugging. So you can debug from JavaScript into WebAssembly into the Rust code and back. And of course, you can also use a Java debugger to debug the Java part. So there's a lot to discover in that demo and a lot to see. We have all the pieces in place. And right now, you can do JavaScript interoperability, essentially. The WebAssembly community is working on a really big proposal called the component model, which essentially, the goal is to turn WASM modules into WASM components, and the only difference is that they expose a certain interface and they consume certain interfaces. With that, you can stick them, you can link them together, and that will allow language interoperability. Another promise from WebAssembly, and component model, I think, is what's to be expected. So what they have is called a WASM interface type, I think. It's called WIT, the WIT format, in which it's an IDL, and you define your interfaces, and then you can generate the corresponding code, just like, I forgot the name of the Apache project, Apache Arrow? No, that's for data exchange. There's some, Thrift. Yeah, that's right. Yeah, it works like that. And then it doesn't matter what language you use, as long as it can be compiled to WASM. And so in the future, I expect that it will be possible that you can generate a Java interface from this WIT interface, and then you can use the WASM component in the background through GraalVM, and you don't even know that you're using WASM. You're just programming against the Java interface.
But you could do this right now, because if you have JavaScript, you should have the truffle description as well. From truffle, you can generate Java, right?
Yes. Well, from truffle, we cannot really generate Java, but what you could do is you could generate Java interfaces for the JavaScript binding, and then you have a similar experience. You still need JavaScript in between.
Why?
What do you mean? Why?
Because my understanding is that the WASM compiler, it generates the WASM plus JavaScript like a binding, but no one cares about the JavaScript part, I would say, right? Because it's just a wrapper around to make it nicer. And as I recall, in JavaScript, this is more or less byte arrays were transported back and forth, right? But if you have the JavaScript description, you have indirectly the truffle structure of the JavaScript, right?
That part is language independent, and yes, I guess we could use truffle to generate these interfaces, but we have that type of interface generator at the moment. So the problem why you need a JavaScript binding is, let's take a string as an example. Rust decides how a string is laid out in Rust memory, right? And C++ could decide otherwise how a string is laid out. So there's no way from Java, because you don't know what WASM module you call into, you don't know how the string is laid out, right? So somehow that conversion needs to happen, if any is necessary. And right now that happens in the JavaScript binding. So the JavaScript binding translates JavaScript objects into the target object, and the binding knows how a string is laid out in memory, because that has been generated when you generate the WASM module, right? So it's generated by the same toolchain, by the Rust compiler, by the C++ compiler, and so forth, right? So with the component model, it will add string as a data type to WASM. And then you have several layouts for strings, and we can target those. And then we can do truffle interop with component model. But right now we can't.
So the reason is you are borrowing the WASM compiler from somewhere, and the tooling is outside of GraalVM, and this is your problem, because what they generate WASM bytecode together. Is it bitcode or bytecode?
It's bytecode.
Bytecode together with the JavaScript definition, and this is outside of your thing. But if you instantiate it with GraalJS, then you have the truffle description, right?
Yeah, well, what a Java developer wants to do is they want to develop against Java interfaces or Java classes, right?
Or and reflection, you could start with a very primitive reflection language.
Yeah. Well, reflection is no problem. So what Truffle provides you with on the Java side, when you embed the JavaScript binding, is a value, and on that value you can call a method like invoke dynamic essentially. But what's really, really cool is value has an as value as function, and it takes an interface. And if you use that, Truffle will create a dynamic proxy for the JavaScript object, and then you get this proxy implements that interface. So what you do is you can program against the Java interface, and when you call a certain method, it will be sent to the proxy, and Truffle redirects it to the JavaScript object, and then the JavaScript object will do the communication to WASM. And that sounds kind of crazy, but it works. We also do this on the Python side. On the Python side in GraalPy, we are actually working on an interface generator. So you can generate a Java interface for a Python package. And then you program against the interface, and you don't even know that you're using Python under the hood. It looks a little bit like Python, right? Because the methods are called like Python methods. But you get to some extent even the type safety from Java because you're using interfaces.
This is do you remember RMI? No.
Yes, of course. Yeah.
Yeah, really. So this is a similar principle, right? You had an interface. You call the interface, so dynamic proxy, who translated the calls to a RMI protocol and send, the messages back to the server. And this is here, and there's no remoting, but you're translating to JavaScript. But still, just out of curiosity, so I think it's a good approach what you do. But if you run JS on Graal, so then the JS, you need a truffle for it, right? Behind the scenes.
Yes, you need truffle for it, but you also need truffle for WASM, right?
Yeah, exactly. So you have two truffles.
That will be shared. Yeah.
Right. And if you have the truffle, you can somehow capture the truffle and then call it directly from Java. You know what I mean? So there is a kind of JavaScript because you got that from the compiler. So you got from outside the JavaScript WASM package, and now it runs on Graal. As it starts running on Graal, you will have truffle from the JavaScript, which you got, from the external compiler, plus the truffle for the WASM. So actually, you can skip the entire JavaScript syntax and just use the truffle behind the scenes to call it, right? So technically.
Well, technically, yes. I think I know what you're thinking about. Well, when you run WASM and JavaScript on Truffle, they will actually use the same Truffle. What we want to do and what we're waiting for is that component model lands in the WebAssembly spec.
Yeah, sure. I'm sure this is better approach. But for now, just from my understanding, I could just, if I had the Truffle, I could run it once. I see the structure and then call Truffle directly without JavaScript. This would be technically possible. It would be a hack. But it could work, right? So just from my understanding.
Yes, something like that could work. Although, like the reason why I think the JavaScript to WASM approach right now is simpler is because JavaScript has a WebAssembly API, right? And that is actually used, and the compiler not only spits out the binding, but it also spits out the code that marries the JavaScript binding with the WASM code. Right. So, and you can just run that on GraalVM, and that is using the JavaScript to WebAssembly API. So that all sounds very complicated, but it really just means instead of calling like primitive data types and or dealing with pointers, which you would do in WebAssembly on the WebAssembly level, you interact with high-level complex objects from JavaScript. Right?
Yeah, it is reason. I'm with you. For you, it is reasonable to use the already existing JavaScript functionality because you can run it anyway. I'm just thinking, how it works behind the scenes. And for me, the WASM needs an interface, which was provided by JavaScript. And this interface you have to run somehow anyway. This is maybe truffle description, but you don't care about that because it's hidden for you. But if we had it, we could just call it directly with lots of pain. And now,
yeah. I think the better user experience would be if the WASM compiler, so Rust-C that compiles to WASM, not only spits out a JavaScript binding, but also a Java binding.
Yeah,
right. That would be much cooler, and that is something that I think we can achieve with this component model.
Yeah, sure. Because it's part of the spec. Then what I understood, the standardized is multilingual, like almost like Corba. It's an IDL.
Yes.
The same technology, 20 years old, right?
Yes.
Interface definition language, and if you have the language, you only need a binding for all languages, and you are basically set. So this is what happens. And what I thought right now is JavaScript already has it and is somehow compatible to Java, so we could rely on it, but it will be hacked. Your approach is better. I'm just from my understanding, because right now I'm working on MCP, Model Context Protocol, and there is a tool, and you have called external tool, right? And what I wanted to do in Java, provide a kind of an interface, but if I provide an API, I need it as a class path, and I wanted a generic solution, very simple one. So, and my thought was, why not just Java function? So the external tool with Java util function, this basic one, is just one call, and the return value is a map. Record would be nicer, but there still would have to record somewhere, and service loader, and I was set. So it works, and this is something similar. I mean, this is a WASM I have to call somewhere, and maybe Java function would be an ugly but good enough abstractions, and I could write around the Java util function and type safe interface, and it and it will call it basically what you said with dynamic proxy. This is a more sophisticated approach, but yeah.
Well, GraalVM is also 100% compatible with native image, so you can compile your Spring Boot application that embeds WebAssembly with GraalVM to native. That's also something that the Photon demo does on GitHub. GraalVM is currently compliant with WebAssembly 1.0 spec, plus some feature extensions. So you can actually find the whole list on the WebAssembly website. They are listing different runtimes and their compatibility, and GraalVM is among them. In the next release, we are, by the way, targeting WebAssembly 2.0, which is really good. And it's 100% Java, right? So it's really just a Maven dependency that you need to use.
The WASI is also interesting because this WASM itself cannot call anything. It was just like just compute. But with WASI, you have the possibility to call system interfaces. So you can actually open a file, right, with that, or write to a file.
Yes. So that's the key part that makes WASM now relevant on the server side, because you can run it on a node or WASM time or some other WebAssembly runtime and start a server, for example. So in the future, that may be how you could compile Spring and run Spring on the cloud.
Or Quarkus. This is what
or Quarkus or Micronaut, right?
Yeah, Micronaut, Quarkus, right? Exactly. Yeah. So I mostly use Quarkus and Micronaut because of faster startup times and less memory. So this is this is why also the question.
So maybe this is a good time to switch the topic over to WebImage.
Absolutely. It is very good time. But the last question maybe: what do you expose via WASI? So files, sockets, everything, or how you do this? Because you need a mapping between the WASI and Java, right?
Well, we implement WASI with Java, right? And we can do that because, well, we have implemented the system interfaces for many languages already, and WASI is just another one, right? From our point of view. So WASI is a spec, and we implement that spec. It's very POSIX-like, right? So it's not that hard to support. I don't know from the top of my head what it supports, but it's like opening sockets, opening file handles, reading file handles, and so networking.
That's cool. So we have WASM in the middle and Java around it, right? And and the WASI is like Java implementation to access the operating system, which means probably is also secure. Because you can intercepting all the calls, and you can specify what is allowed and not allowed, right?
Yes, and you can sandbox the whole thing. You could run untrusted Rust code compiled to WASM in your application that way, and it will not be able to access the internet, open file handles, and whatnot.
And this is now the killer feature. What is the first use case? Because now you can say, "Hey, I'm building a cloud. just give me your code and it will run safely on my machine, and this is stellar.
Exactly. Yeah, so before we talk about WebImage, maybe that is also another interesting use case that I should mention. So, of course, native extensions is not just a problem in Python. In Java, it's also a problem in Python, right? Most of the ML packages, they use native extensions, right? So what if you want to sandbox them, and what if you want to run them securely? What if you even want to use them in Java, right? So with GraalVM, we allow you to do that, and we even allow you to call out a native extension, something that Jython never supported, right? But still, like if there's a security vulnerability in the native extension, then you're screwed because it's outside of the JVM sandbox, right? So what we have seen, or what we are actually looking into and considering is there is a project called Pyodide, and Pyodide is the CPython interpreter compiled to WebAssembly, and a bunch of Python native extensions, including NumPy, SciPy, and so forth, also compiled to WebAssembly. So that Python runs in your browser, but you can also run it securely on Node or on some WASM cloud, right? And what we could do in GraalVM using GraalVM is leverage these two WebAssembly compiled Python native extensions in GraalVM, right? And then we can scale again. It's like the WASM integration in JavaScript. We could have the same integration for Python, and then you can securely execute Python code, and you can scale it really well across your Java threads, right? So that's something that I think is really exciting. So, and the team is currently looking into it.
And the last one, and then we have really switched topic, because actually the second topic for me is really interesting. So, and having the WASM component in place, what you could even do then, I guess, so you can have Python with a native extension in Python, and then and let's say a legacy enterprise Java application wrapped with an WASM component, and you will get an integration through Python to enterprise legacy Java, running everything in one,
Yeah. Well, for that you wouldn't really need that integration and take the detour through Python. I think you recently talked to Christian, right? Christian Humer about Espresso. So that's what Espresso can do today, right? You can embed Java 8 code in your Java 25 applications.
No, this is what this is not what I meant. You have an already existing Java application, and it already runs on GraalVM, right? And Python does not anything about Java. So, and if you have a native extension, this native extension from Python could actually call another native extension implemented in WASM, which calls Java, right? So we have this component to component communication, and the old enterprise application would be not aware about that. It's just a linear WASM. And maybe in Python, it's the only way to do that, because if they don't know the extensions, an extension communicates extension, just additional integration point, which was not possible before. And of course, with Graal, Python could directly call Java without any ceremony, right? So this could also work via truffle.
Yeah. There's a lot of things that you can do. Right now, we try to keep it simple and focus on a one-to-one relationship. But of course, you can go full polyglot too, and have these components talk to each other, independent from the language they're implemented in. And that's generally for all our Graal languages. We want to make them feel just like Java in your Java application, right? For a Java developer, like it's nothing better than programming against normal Java interfaces. And you think about the interfaces and you don't care about how it's implemented. That's what you do with third-party libraries anyway, right? So whether it's implemented in Python, in Java, in C++, should it matter? I think no, right?
Yeah. So now, why are you borrowing JavaScript compilers who create the JavaScript external compilers which create the JavaScript with WASM, when WebImage can compile Java to WASM, right? So now,
well, that is a very different topic. So now, like, if you're listening to this and you're confused, well, make sure what we're talking about now is something related, WebAssembly related, but also totally different. So WebImage is a new preview feature that our team has been working on in the last couple of months, and similar to native image, it allows you to compile your Java code or your JVM bytecode into WebAssembly.
Bytecode, right? So this interesting part. Input is bytecode. and
Yes.
output is WebAssembly.
Yes. Well, our input for native image is also JVM bytecode. So native image also works for Scala and other languages, right? And the same tool chain we essentially extended with a new Graal phase that allows to emit WASM instead of ELF code or AMD64 code, something like that, right? So instead of an executable that runs natively on your computer, you can actually WebImage can actually produce WebAssembly modules, right? So that means you can compile your Java code to JVM bytecode, and then you have your jar files, and then you can turn that into a WASM module and run it in the browser or run it on Node. And we did a presentation of that at WASM.io earlier this year. And if you search for GraalVM demos, and maybe you search for WASM in there too, you will find the WASM Java-C demo, where we have compiled the Java compiler, Java-C, to WebAssembly, and then you rerun it in the browser, and you can do crazy Java compilation, like Java-C compilation in the browser. It is a bit crazy, and I encourage you to maybe watch the talk and not play around it yourself, because then things hopefully make a bit more sense. But we chose Java-C because everyone in the Java community knows Java-C, right? And it's much more complicated than a hello world. We've learned the hard way when we launched native image that for a very long time people thought native image can only do hello world, right? But WebImage, even though it's a preview, it can already compile Java-C. Right, so
that's crazy. So this is meta-circular on complete different level, right?
Yes. So in the demo at WASM.io, we compiled Java source code to JVM bytecode in the browser. Then I downloaded the file, which was created in the browser, downloaded the file to disk, and then because that is JVM bytecode again, we compiled it again to WebAssembly and ran it on Node. Right, so that's something that you can do, but you don't have to. Well, the question is, why would that be useful, right? First of all, obviously, like running Java in the browser is still interesting, and it's also some sort of blast from the past if we think about Java applets, right?
Yeah.
If you are in the WASM community and you look at WASM cloud providers, Java is just missing in that space, and that's something that we think GraalVM can actually solve, and we can bring Java into that ecosystem. And I think it's a match made in heaven. Native Image's goal is to provide cost-efficient deployments of Java, right? So that's something that we can do. And WASM on the server is also about cost-efficient deployments. Right, so it's the same goals. They align. You still get really good startup, compact packaging, minimizing attack surface, and so forth. Right, so that's why I think that's a really good match. So now about the use cases. One thing that we have done is with the Java-C demo is compiled a command line tool to web, right? And that's actually a very interesting use case. And we actually have done this in a real production setup. So as you may know, there's this GraalVM dev kit for Micronaut, which is essentially the Micronaut build from Oracle. And there's a launcher, like the Micronaut launcher, or the Spring initializer, right? And that launcher produces GDK Graal dev kit projects. And we had that implemented as a command line tool. So then we decided we want a launcher in the browser because there's Micronaut launch, there's Spring initializer and whatnot, right? So instead of building a server that does this for the user when the user requests this, right? We compiled the command line tool or most of the code from the command line tool to WASM, and then sprinkled some JavaScript and HTML front end around this. And that's what you get when you use the GDK launcher, which is very convenient because, well, we work in Oracle. And if you want to launch a service like a project creating backend, right, that needs to go through all kinds of reviews. But serving static files is totally fine. And creating the project on the client is actually really, really cool and useful, right?
So what do you get as a download is a jar from browser?
You don't get a jar, you get a WASM module, right?
Okay, but what I thought what you could also do, you could implement the launcher like a CLI, and the launcher usually creates a project, right? Project template. So you could stop there, and the user will download, the project from the browser, the Java project. Not you can omit the last step. You know what I mean?
No.
If I use a CLI, I can say, for instance, Quarkus create app and the app. So what it does, it will create, it goes to the internet, downloads modules, and it creates for me a Maven project with some Java code, a very simple one. It's just, but by the way, I think it's even a Mandrel or GraalVM image, the entire CLI. So, and I could do the same in the browser. So instead, you go to the browser and I say, Quarkus create app. So this would be a WASM. And it will create a package, a zip package with my Java template. It is not a bytecode, and I will download, the Java package.
That is exactly what this thing is doing.
Yeah, but you say, but I'm not downloading WASM. I would my output would be a Quarkus project.
Yeah. Okay. Yeah. Well, I was not precise enough. What I meant is your browser downloads WASM. It doesn't download a jar.
Exactly.
Right? You see the website and you choose your features that you want, right? And you press generate project, and the zip file is created in the browser on the client and saved to disk. And you unzip it and you have your jars.
Very good. This is what we speak about at the same time. Same thing. Because this is perfect. This was brilliant. And another use case would be, for instance, imagine you have some heavy calculations. And JavaScript is not always precise. So you can test the entire thing as Java with unit tests and whatever, and then convert it in WASM and use it from regular JavaScript applications. And you have then, an audited and encapsulated algorithm, right?
Yes. Yeah.
And the killer feature for me, are simple things. So what you sometimes need is, you need just to check or rename some headers. HTTP headers. And in all cloud providers, this is like the edge, is the specific name for it, not edge computing, edge function, something like this. There's like kind of a gateway, a cache, for instance. In
like a middleware thing. Right?
Yeah, middleware, not even middleware. It is like the frontware, because it is very on the edge. And there's a first thing, what happens, you get hit this. This is usually part of the API gateways, CloudFronts, or not CloudFront, Cloudflare. Is another vendor, exactly, and they have the workers. They are on the edge, and they can be triggered by cache changes or whatever. So and they usually accept WASM.
Yes.
Yeah, but what I would like to do is, I already have my Java pipeline and I have the Quarkus, and actually add the same header in the Quarkus and on the edge. So I would like to write a very simple Java method which just renames that, test it on Quarkus, write a unit test, convert it to WASM, and ship it to the edge. This would be very enterprise, use case, which from time to time I need it. And with that, it would be brilliant to do, right?
Yes, that's definitely something that we can do. That's essentially the user-defined function use case.
Exactly.
Right, you provide a user-defined function in Java, and hopefully you already have written that code, so you can just reuse that code in the best case, right? And instead of embedding it in your Java or using it in your Java application, you can export it to WASM using WebImage, and then run it on some WASM-powered cloud edge. Yeah.
And you have one single code base test, one single pipeline, and two outputs. This is the classic one. This is why I asked you a few years ago already. We really need it. But what you did with the micronaut, this is crazy. So I have to say, your use cases are really cool. So not cool, they are impressive because you really see the power, right? So this is why you should do this, because it is possible, so we can do whatever you like, right? So this is actually the message.
But recently, like last month, I caught up with Josh Long. We met in Amsterdam while we were invited by the fine folks at JetBrains. And in the evening, he was like, he's really excited about WebAssembly 2. And he has seen the demos, and he's like, I really want to do Spring, right? So obviously, like there's still, because it's a preview feature, there's still a lot of stuff is missing, like threading, networking, graphics, right? That we don't use WASI at the moment at all, which would allow you to do system calls, right? We only do JavaScript embedding at the moment. So if you need to do something with files, you need to write that in JavaScript and provide a handle for that, right? So Josh was like, wow, I really want to do Spring. So on my way back from Amsterdam in the train, I thought, okay, well, how about I give this a go? And I did not try, obviously, a Spring server because we cannot do networking or threading at the moment, but I tried a Spring shell. And the Spring shell already brings up the whole application layer of Spring, right? So it took me some time, but after like halfway back to Berlin, I got this working, right? So now I can run a Spring shell on Node or in the browser, right? So, and that demonstrates that we can bring up the whole Spring application stack already. So all we really need is threading and networking support. And then you could compile a Spring Boot or Quarkus or Micronaut application to WASM and run it on the edge, right? Or run it on a WASM powered cloud.
Yeah, also in contact with Micronaut? Because this would be...
Of course. Well, a lot of Micronaut engineers are working on a sibling team, essentially, like the Graal dev kit is not too far away from the GraalVM team. And Micronaut was the first to support native image, and I'm sure they will be the first to support WebImage too. Well, not the first. I mean, like the first time they released, they had native image support, right? And I'm sure the moment WebImage is a thing, they will support that too.
And hopefully Helidon as well.
Well, I think so, yeah. Well, at the end of the day, there are all these frameworks built on Netty, right? So, or some other like Tomcat or something, right? So the question is, what does it take to get these to work on WASM? And once we have figured that out, it will just work across all these frameworks.
Yeah. What is the tooling or process? Let's imagine I have a Java method. This would be my case. So Java method, and I would like to create a WASM out of that. So what I would have to do or how it works?
Yeah, so right now, this is a preview and things can change, right? So maybe what I say now is not accurate anymore in a month. But right now we have a little API that is like an add.js object and stuff like that. And again, this is used in the Java-C demo, and you can see the sources and compile it for yourself and run it. So essentially what you need to do is you need to annotate the methods that you want to export, right? So that's what you do. And then you run a native image build. Right now, WebImage is embedded in native image. You run with a specific flag. Right now, that flag is called --tool /svm-wasm. So yeah, this is really hidden, a really hidden flag, but it's you can find it in the Java-C demo. And we will certainly rename that in the future. But then you end up with a WASM file and a JavaScript file, and the JavaScript file exports the methods that you want. Right?
And why are you still using JavaScript and not Java now?
Well, because the component model is not finalized yet, right?
You're still relying on the JavaScript interface.
Yes, we still rely on the JavaScript interface. So that is also something that we need to work on. So component model is not supported yet, but that is definitely something that we want to do. Well, at WASM.io, a lot of people from the Bytecode Alliance were there, the people that are maintaining the WebAssembly spec. And they were not only looking forward to the talk because we're adding Java to the list of WebAssembly ready languages essentially in the future.
So they are open for it, right?
Not just open, they are really keen even to collaborate and help. Right. So, and that's exactly what we went there for, right? We wanted to see, we're looking at this point, we're looking for community feedback, right? What is it that you want to do with this? And then also for collaborators and contributions. I'm guessing the Quarkus team is also very interested in this too. And we have a good track record with the community to work on such things. It's a massive undertaking to support the whole JDK in WASI, right? For example, that's a big thing. I think our team has already produced a very solid foundation because we can run Java-C, right? We can run more, but there's also things that we need to work on together with the WebAssembly spec or the Bytecode Alliance specifically. For example, the JDK has some functionality that is missing in WASI, right? And WASI is just a preview, so there's preview 1, preview 2, and upcoming preview 3. Hopefully includes stuff that we need for the JDK. And similarly on the threading side of things, Java's concurrency model and Java threading is very, very sophisticated, and it's hard to get this entirely or like correctly implemented in WebAssembly, and we need to make sure that that's possible. So there's a proposal, I think it's called something like shared threads proposal in WASI, and that is also something that we now get involved in to make sure that it fulfills the needs for Java, to support Java, right? And we have all these involvements now going on. There is the WASM GC proposal, which allows WASM to use the runtime's garbage collector. In the past, Rust had to include its garbage collector in the WASM module. That was really slow. But if Rust targets WASM GC, the WASM code will actually use the garbage collector of the runtime, which is really, really good and solves a lot of issues. And WebImage already does that. But, in Java, we don't only have very good garbage collectors with very good throughput, but we also have very powerful mechanisms like read references, soft references, phantom references, right? And they all need to be correctly supported on WebAssembly if we want to push Java and what you can do with WASM to the limit, right?
Yeah. My perspective is the following. So the bytecode in Java is 30 years old, of course, now this year, and it is similar to WASM. And this is maybe the problem, because if you're talking with Java developers, say, okay, we don't care about WASM because we have Java, but the industry really considers WASM as a portable way, like a bytecode without Java, and it is already a fact. So we need, a way to integrate WASM with the Java ecosystem. On the other hand,
or to bring Java to these platforms.
Yeah,
right?
exactly.
Every browser has a WebAssembly runtime, and we should be able to run our Java code just like Rust or Go engineers can build for browser, right?
On the other hand, the Java engineers have far more experience than the WASM. This is 30 years versus 5 or 10. This is like, it started with the Mozilla project 5 to 10 years ago. This is a relatively young project. What was it called? ESM, right? How is it called? There was the first name was like a subset. It was a Mozilla project subset of JavaScript, which was very primitive.
Didn't it come out of Mscripten?
Exactly. So it was very primitive subset of JavaScript, which could be executed fast, and this was the start of the WASM. So now, and if we provide the experience from Java back to WASM, not only will be more compatible, but Java will be the first class citizen, and we could very easily integrate. So and what I forgot, actually, there's not only reason why the industry didn't want it to use Java bytecode, because WASM is a bit different, right? WASM is stack based, I think, and with bytecode would be harder to implement the same thing. Wasn't it true? They had technical reasons to use. No,
that is just stack-based is just very easy to implement, right? But a bytecode interpreter can be stack-based. It can also be register-based.
Okay,
so that it's just
Because I have a conversation with a WASM engineer and told me that there were technical reasons. Okay, maybe, but yeah.
Yeah, well, yeah, these are just design decisions, right?
Okay.
In Truffle, for a very long time, we thought about AST interpreters because they're really nice to implement, but at the same time, they have a lot of memory overhead, and startup is very bad because you need to build up these data structures, and bytecode interpreters are much more efficient. So right now, the Truffle team works on bytecode interpreters mostly. We even have a DSL to do that, to generate bytecode interpreters, and hopefully we will use that in GraalPy, GraalWASM, and so forth in the future. So we're shifting from AST interpreters to bytecode interpreters.
Okay.
Our users don't notice this; the behavior is still the same, but memory consumption and startup improves, right? So that's something that,
So I think there's also very important projects, and of course, what you can also do is stored procedures in database, right? As WASM would also work.
Yes, of course, you could do that. So the Oracle database and MySQL already integrate JavaScript through GraalJS.
Exactly.
So JavaScript has a WebAssembly API. I said that earlier, right? So now maybe you can put one and one together.
Exactly. Thank you. It was really interesting to have you back. after 3 years is important. So I have to reinvite you more often.
Yes. There's so much more we could talk about. We have just announced Project Kramer, which brings an Espresso-like interpreter into native image, and it can do dynamic class loading and stuff like that in native image. Yeah.
So we will schedule another meeting. Okay.
Yeah, well, there's many more people in our team, and maybe you want to invite them too. But I'm happy to talk about that as well.
Perfect.
So there's so much to talk about. We're very excited. But yeah, it was great to talk to you about WebAssembly and how GraalVM fits into that picture.
And where people can find you in social media.
I'm on the GraalVM Slack if you want direct messages. But yeah, you can find me on almost all the platforms. My handle is usually fniephaus, Niephaus. That's my user handle, and I use that almost everywhere. Feel free to reach out if you have any questions, if you're curious, if you have any feedback. We are all ears. We want to make sure that we're covering your use cases. And if you want to get involved, also hit us up, and we're happy to collaborate.
Yeah, thank you a lot.
Of course.
See you next time.
See ya. Thank you, Adam.